Okay, let's go ahead and jump right into it. So here is day 4. So a brief review. If the response variable is quantitative, the explanatory variable is quantitative, and this were to be a stat class, which method should we use to analyze the situation, right? Hopefully you all think to yourself, take a moment and remember that would be a simple linear regression. Okay, and then if the response variable is quantitative, the explanatory variable is categorical, and this were to be a statistics course, which method should be used to analyze this data? If it's categorical, it's one way ANOVA. If it's categorical binary, it's either two independent population means, aka the Welch t-test, or under certain conditions, it could be the pooled t-test. Or yeah, pooled t-test. So in this class, we're interested in predictions. Okay. But the thing is, this class is it's small in terms of what needs to happen. So if you're a data scientist, I would argue, I wish this font was bigger, but it's okay. I would argue you need to know why things happen, why things are occurring. Explain the variability in the response variable. Okay, fine. In the response variable, that is statistics. That is statistics. I'm sorry, it is. However, within statistics, you also have the capacity to make predictions. And that's what we're after now. That's what we're really after. In a stat class, I can take more time and be a little bit more delicate. But in this situation, once we know that one of the regression coefficient is, is significant. I'm assuming that you've heard that in your stat class, or if you haven't, that's fine. But once you know that the p-value is extremely small, right? We can use it to make predictions. Okay, if that's all what we have, we're going to use it to make predictions. I feel kind of iffy even saying that because I'm a statistician at heart, but we're going to use it. We're just going to use it. So let's pause and let's talk about this particular data set. Okay. So I combined a few things. So from the data science video, I combined the actual reading of the entire data set, and also combined what we did yesterday. So if you remember, we're using absences to predict salary, okay? And so what I had you all do is I had you plug in, right? I made you do this, right? I said let x equal be 25, and really you shouldn't make that prediction because you don't have data near there in terms of absences, right? So if you were to do a little table, let me just show you, just so you all can. This will give me error, and I want you all to know why in a moment. Table $, let's say absences. And if you guess why, it's because, take a moment to think, why should this give me an error? Right? HR data frame doesn't exist because I didn't run this chunk yet. Okay. And so table now works. So you can see in terms of plausible values, you have 1 to 20. So the 1 occurs 14, 20 occurs 14 times, 14 occurs 17 times. Okay, fine, fantastic. Okay, so with that being the case, I taught you how to do it this way, but watch this. I'm going to use this function called predict. And I'm going to use the model. I need to make sure I run this, model 1. Okay, and I'm gonna type model 1, comma, data frame. Okay, data.frame is it's a function that's really nice, that allows me to create a data frame. I'm gonna say absences is equal to 19. Oh no, run it. Boom. It makes it a prediction for me. So let's say you don't believe this result. Let's do it by hand. 395.3 plus 351.1 times what? Times 19. Boom. Almost. There's a little bit of a discrepancy, but I'm fine with this answer. Okay. So that's kind of cool. Okay. And this predict function works in the same manner, even if it's a categorical binary response or categorical response. So if you remember this, in a stat class, I would have done a little bit more explanation. Something else is going on here, but if you come to learning hours, I can assist more. But let's go ahead and run this and let's make a prediction. So we run this, boom, model 2. And one of the things I'm going to do is I'm going to use that table function again. And we see that these are the 3 levels, or 4 levels that are possible. What I'm going to do is I'm going to say I'm creating a new R chunk. And then I'm going to say predict again. And let's say we have this new employee that we know that their performance, we're going to use model 2, because that's what I named it. If you didn't know, I'm going kind of fast, my apologies. I named model 2 up here from yesterday, model 2. And I'm going to do comma. And if you want, you can pause this video and finish the code yourself. You tell me what it should be. Okay? Data frame. All right, performance. Let's say that, what I said. I think I said that their performance is equal to, we're going to use quotes here. Okay, that's the difference if you got an error. We're going to say that they exceeded. You know, make life easier. Yeah, exceeded. We should get 77,145. So hopefully that works. Let's see. So put this here. Boom. 7,144. It's a little bit off. There's some approximation differences. What's happening here? That's why. Either this is rounding or it's doing some approximation differences. So let's say we're doing fully met or fully meets needs. So let's just copy. All right, fully meets. My apologies. That should be just fully meets, not needs. And when I run this, it should give me a prediction. So 68,336. It's a little bit off in terms of decimals, but if we were to do the calculations, 77,145 minus 8,778, almost there. You can go into more documentation, but that's the purpose of this. So we can make predictions. Now the kicker. Now this is going to make our life a lot easier. Now let's say we want to create a model that has more than one explanatory variable. So let's call this model 3. We do LM for linear model. We say we're going to predict salary, right? And we want to do and mind you, the model 2 is a little bit more complicated. And if you're curious to come and learn more, statistically speaking, it's worth noting, but there's other things going on there. Okay, so performance score. I'm gonna look at the head. I'm looking at the head of head is a new function, that you can use of data frame. Okay, I'm gonna look at, let's say right now we can throw anything in the model. We can do gender ID is kind of dangerous. Let's do, you know what? I'm just gonna look at it like this. I'm gonna say let's do marital description. Let's do that. Let's just do 2 categorical variables. So now it doesn't matter. We can do married. Come on, Emmanuel. Column names. Another function. Column names. Teaching you a bunch this time. HR, DHR. Okay, so I can do. It gives me the column names of my data set. So what I can now do is marital. That's right. It's right pronunciation. Okay. Comma data is equal to HR data frame. Okay. And then we can do summary of model. Again, there's so many more things that you can do. We're just scratching the surface, right? So here we go. Complication. Some of these p-values are not even worth noting. But let's say we needed to make a prediction. I'm going to do a little game of copy and paste so I can make our lives a little easier. So copy this, create a new R chunk. Again, I'm going to post this code online. So performance is equals fully met. Let's say that's what we're interested in. And let's say we're also interested in marital. We'll do a comma within the data frame function. And the reason why we're doing that is because we're setting the data frame in such a way that we are saying, okay, this new person that's in our model, this new person, we want to be able to predict what their salary will be based on this criteria. And this is the way we set the criteria. Hopefully that makes sense. So let's say that they're single. Okay. So there's an inherent issue if someone knows this. First of all, when I run this, I actually get an error because it says model. Oh, I should have gotten an error. Most likely they're ignoring this marital description, but the appropriate approximation should be based off of model 3. Hopefully I named this model 3. Yeah, I did. So this should be a little different. Yeah, exactly. So it's 69,297. Okay. So that is our prediction. So one of the things that is wrong with this is because we don't necessarily know if we have a person within our data that fits this situation. Okay. One of the ways for us to check if we do have data near there are data according to this situation, someone who fully meets the performance score as well as marital status, right? What you would want to do is do table of HR data frame, and then we'll do marital status, marital description, and then comma HR underscore DF $, what's the next one? What's the other one? Performance score. Okay, so here, do we have data on this? Fully meets, and they're single. Yes, we have 104 individuals. We can make predictions. Now, let's say if it needs improvement and it's separated, you better not make a prediction. You better not. So, sorry, I'm having fun. So that is that. And mind you, we could build a model on variables that are quantitative. So in traditional stat class, this is called multiple linear regression. You can treat this as a multiple linear regression or more so like a linear model, or this could be seen as a two-way ANOVA because you have two categorical or categorical binary variables predicting a quantitative response where you're really interested to see if the means are the same. But we're using this to predict. Okay, you're using this to predict. All right. So I feel weirded out because I'm using these models to make predictions in machine learning, right? We're trying to make predictions and and see how far we are from the truth. But at the same time, we're not losing faith in our statistics because statistics explains why things are the way they are. Okay, so we still have value in statistics. All right, I'm done.